Our next presenter has been a really strong supporter of our conference pretty much from the beginning. And he's a guy that comes across some of our companies that are doing presentations and says, hey, listen, I like that technology. I'm putting it down on my farm. I'm going to make sure it works. So he's a true in the field guy who's getting involved in all this precision ag stuff. So you'll really enjoy his presentation. This is Chuck Baresich. Chuck has a BCom and ag business degree from the University of Guelph. He and his brother Justin have farmed in the Bothwell area in Ontario for the past 20 years in a long-term no-till zone system. Precision agriculture and technology has always been very important to their farming operations, from the basics of equipment to steering and planting controls. Chuck has been the general manager of Haggerty Creek Limited since 2008. He was previously with Farm Credit Canada for 13 years, as last posting as development manager for the Essex, Kent, and Lambton County. Please welcome, I'm gonna play you a video first, and then we'll welcome Chuck. Well, you got to see a little bit of the technology that Chuck's using on his farm. Chuck, take it away. You can tell us a little bit more about what you're up to.
All right, thanks, Andrew. And I thought that it was fun to have live in-person demos again. And so we actually thought it'd be really interesting to demos to have all of our autonomous vehicles all in one place, all on the same day. And that happened here back in September. And so I thought that video was a nice event to share with everyone. The purpose of my talk today is going to be working with autonomy and the autonomous weeding that we had done and some of the other technology that we had worked with this year. So I'm going to go through this as best as I can. Andrew already introduced ourselves and who we are. We see autonomy as a natural extension of our agronomy business. The data collection, field computers, precision agriculture as applied technology, it all, automation is a natural fit. And that's why in this year we started a new company called Haggerty Ag Robotics to warehouse all of the automation technology that we are working with. And in 2021, we worked with several different robots, obviously from Raven, the OmniDrive, the autonomous kit for a tractor, and the OmniPower, which is formerly known as DOT. We also did lots of testing and trial work on Correcchi's Romeo HCT, which we had custom designed for our needs. We have the Oz robots from Neo Technologies of France, again, the small scale autonomous tool carriers, as well as the Dino, which just came late in October, which is a commercial scale autonomous tool carrier. We also spent some time with the Nexus Goat, which we'll talk about later, a commercial scale autonomous weeding tool. And we did some work with drones, both for spraying and for spreading. So we had lots of activity in 2021. In this presentation, I do want to thank Ian McDonald from OMAFRA for some of his content that he graciously provided to me, as well as Auger Ag Media for some of the video and pictures, and our summer student, Teresa Van Dam, who worked with the robots along with Grant on our team. And she actually prepared a lot of the content for this presentation. So I'm not going to spend a lot of time. I have talked about OmniPower in the past, but we did use the OmniPower and fertilizer spreader again this year, both to spread fertilizer and lime. I'm really excited about the fact that we were able to demonstrate multi-machine functionality. So the ability to have a person, like a human, operating one machine in the field and have the OmniPower operating the other, working in coordination. So that's quite exciting and quite an advancement. We also have used the OmniDrive, the autonomous grain buggy now, for 1,000 acres of crop harvest on a John Deere 8260 and an S680 combine in both corn and soybeans. So that can be another presentation. I did include a small picture, and this shows the operator in the Terrigator spreading potash. So that operator has the controller for the OmniPower in the cab with them in this case, and they are able to work together, and they can see each other, on the screen, so they know, each one knows what the other one is doing, and all the coverage is overlapped. And then this is just a short video clip. I apologize for any choppiness of the video. That just shows the two of them operating together. And again, thanks Ian for videotaping that. It was quite exciting. I believe it's one of the first times this has ever been done. And then we put we've had the OmniDrive on 2 different tractors this fall. We had it on a demo tractor initially, and then we moved it to this tractor later on. You can see on the screen, if I use my, if this laser pointer item works, you can see that we're using Raven RTK to integrate with the tractor. It has cameras mounted here. You can't see the radar on the front, but there's cameras on all 4 sides for safety and perception. And this allows the tractor to operate without a driver. And my brother has been the one running it, and he let's try to get rid of this laser pointer now. And so he did take a small video with his phone of himself. It's a little bit choppy, but there's no driver in the cab of that tractor. It is full. So he finished the pass, and now he's just watching it as he sent the tractor off to the unload zone at the edge of the field. And so the tractor is moving all on its own. And there are some bugs and some hiccups that we had to overcome, but the overall use and functionality of the platform is very far along on the road to commercialization. So we're quite excited about this technology. We were able to use it during harvest and have the driver who was normally in the tractor is the driver who is driving the trucks out back and forth to the elevator. So, the way that we use this technology was to basically have the grain buggy full. When the truck driver came back, they would hop into the tractor, into the John Deere, they would unload it. And then once it was unloaded, they would flick the switch back to autonomous mode. So there's a rocker switch on the arm, and and send it back to be used as in autonomous mode again. We did a bunch of work with soil optics on with the HCT, and both using the soil optics sensor on the robot as well as for doing some clover seed spreading. We also tried it out with tillage with the cultivator on the back. Again, you know, this is like a miniature tractor, and we have, you know, we're quite satisfied with the results of this unit as we worked out. And moving forward into you know, kind of the next phase, early in the spring, we formed, you know, along with OMAFRA and University of Guelph researchers and Ontario Grower Boards, all of us agreed to form an autonomous working group together so we could coordinate our efforts, so that we didn't have, you know, a bunch of different organizations and people all doing the same things. And kind of, we wanted to coordinate this somehow. And so as the season progressed, we expanded the group to include equipment manufacturers as well. We meet weekly. And what the working group does is it helps us determine our research needs to organize cooperative plots as well as coordinated field demonstrations. So we started this process back in February. And again, we wanted to have, you know, have the a coordinated approach. So we reached out to OMAFRA, who has helped lead this process with us. It's been we've been very appreciative of their help. And so what we did is we worked with some nail weeding products. So we had first the Oz on the left and the Dino on the right. That's what we worked with for 2021. And the Oz was used to demonstrate concepts. The idea here is to, you know, what we wanted to show in 2021 is can we use a robot for multi-pass autonomous weeding, or essentially light cultivation for weed control? Now, can this actually be done here? Can we do it using GPS only for navigation? There's lots of talk about using LiDARs and driving between plants and all this kind of stuff, but a lot of these machines are GPS only. And the other piece we want to figure out is the overall logistics of operating autonomous machines. You know, who's watching them? How do you get them to the field? And how do you charge them? And do they actually even work? Do the batteries last? What about the heat and the dust? Like, there's lots of questions that we didn't have answers to. And so what we did is we organized small 2-acre plots with a horticulture focus. We did try them in other crops as well later on in the season, but the main goal was horticulture at the start. A little bit about the Oz. The Oz is a small robot, smaller than a wheelbarrow. It's designed, it's 100% electric. It can operate 8 hours per charge, and it drives slowly, like 1.8 kilometers an hour is its maximum speed, and it works about 1/4 of an acre an hour. And that might not seem very fast when you think about it, but actually it's surprising how much it can get done in a day, because it just sits there and it does its thing. It goes up and down the field. It doesn't ask any questions. It just does what you tell it. The Dino, on the other hand, the commercial unit, is a much larger unit. It still operates that 8 to 10 hours. And the thinking is that this is a normal, like a working day, daylight hour working day. It drives 4 kilometers an hour, and it can do about 2 acres an hour. So, you know, to put that in perspective, the Oz is designed for, you know, around 2 acres a day. The Dino is designed for around 10 acres a day. And in our trial setups, if the crop was planted using RTK, then it was very simple to mark AB lines using the GPS receiver shown on the screen. On the robots, we were able to just, you know, mark the A point in one end of the field, drive to the other end, mark the B point, and then the robot was able to follow those rows. And then all you had to do is tell the robot how many rows, like how many repetitions you want it to go, and whether it had to turn right or left. The other option, if the farmer did not use RTK, is you can mount this rope, this antenna, using a magnet or a little mount right onto the farmer's planter. And then you use an app to mark the AB points as you're planting. And that worked well for rows that were uneven, where the rows got shorter or longer as they went along, or where there's variation, like, especially on hills and things where the planters don't always track truly straight. So that way the robot will follow the marks exactly. So we wanted to collect data on the effectiveness of the weeding technology. We wanted to look at the effectiveness of controlling the weeds themselves, not just the technology. And we looked at Brussels sprouts and cabbage and celery and carrots and a whole bunch of different crops. And we had them in each of these types of crops in the field to various levels. On the machine, the tooling was provided by NAO, and they sent us an assortment of hoeing knives of different sizes, cultivator teeth, blades, brushes, springs, stuff I've never seen before. I'm a corn and soybean farmer, so this was new to me. Occasionally these tools worked excellent, and occasionally they worked terribly. So a lot of it depended on soil type and conditions. So we had to modify some of the tools to better fit Ontario conditions, because obviously, each farmer has some intelligence of their own. And so we were able to modify some of the tools to adapt to existing technology. Some tools were not successful at breaking up the soil adequately, and other ones, like these harrows, performed very, very well. We did find that large amounts of crop residue were a challenge, and soil type and compaction influences the type of tool needed. So when you were on a nice light sand, obviously you don't need very much. When we were on the muck soils at the Holland Marsh, they were very challenging. The tooling can be adjusted to accommodate almost any row configuration, either through tire alignment and tool configuration. So the tools are designed to be very, very flexible on heights and widths and whatever. So that was nice to see. We found that in highly compacted soil, the small tines were ineffective, and sometimes the larger blades left the soil too clumpy. So we found that larger, heavier tines worked the best. Weed control with an autonomous weeder is the same as weed control with herbicides. You need to do it when the weeds are small, because large weed roots will plug up the weeding tools. And so there is so the same rules apply. We also found that excessive depth of the tool can cause the robots to go off course. NAO has since developed an additional weight kit to help that. And obviously, this is a no-brainer. Uniform soil conditions are ideal. That is nothing new there. The Oz robots were very simple to use. They're very straightforward to understand. And the RTK GPS was generally good enough to keep the robots away from the crop. We did find that a poor map led to poor results. And as you can see in this image, if you went over a rock or a tree stump or something in the robot and you went off course when you're mapping the robot will come and map that row off course, as you can see on the line on the left, every single time, and it will not correct itself. So a good map was key. Our RTK issues were generally very minimal. We used the VRS network provided by Case IH across Ontario. We had very good luck with that. The robots have very little issues with wet conditions because they're so light. They don't sink in. And so because of that, they would go in conditions where you would never think of bringing a tractor in the field. And so long as the soil surface, because you're only touching the top centimeter, was dry enough, we had no issues with the tooling as well. The robots could handle most ruts without tipping over, which is also nice to see. There is an option on the robots to have dual tires and extra weight, which help to improve the tracking in tougher conditions, to get the robots to keep driving straight. Obviously, it improves the stability of the robot. To get the weeds that are in between the rows, sometimes multiple passes were needed. So between the rows, weed control was very, very easy to accomplish. And we used side tines, which don't show up that well in this picture, but you can just see them. You can just kind of see them right here. These little soft tines would get closer to the plant. And when the stalks of the plant were heavy enough, we could actually get the weeds in between the rows. The weeds do need to be small. Like that is an issue. On the dyno robot, the dyno is a little bit different. It uses a camera to look down the row. So the dyno robot uses RTK GPS to keep the robot going, keep the tires in the right place. But then it uses a camera to keep the tool carrier lined up to the row. And it also has the ability to go between the plants if the plants are far enough apart. So so it is a more advanced robot designed for different crops. So crop growth patterns matter. One of our observations that we saw that, spreading crops such as tomatoes and cole crops, you have a limited weeding window. You can apply, excuse me, you can insert leaf guards on the front of the tires for both the dyno and the Oz robots that push the leaves away. And these were very effective to allow the weeding to continue for a longer period of time. But there is a limit to what you can do with a spreading crop. And horizontal plants have a huge potential, we feel, for autonomous weeding. We think we proved that this was very, 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 very effective. And also, these machines have a good fit on nursery and berry farms, especially because the rows don't move. They don't change from year to year. So we were actually quite impressed with how these robots worked in these situations. So again, overall, our 2021 observation, they provided impressive weed control. They certainly exceeded our expectations, especially because we were new at the process. A best management practice is multiple passes with small weeds. So one of the things that I observed in talking with farmers is that generally the cultivation and weed control was done as sparingly as they could, largely because of lack of labor. So if you're bringing in a weeding crew or running a cultivator through the field, people would generally only run through that field as often as they had to. And sometimes the weeds would be just a little bit too big. But when you have an autonomous robot, you can increase the number of cycles because you're not under a time constraint. And so because of that, you can afford to let the robots go in there when the weeds are microscopic or very, very small. And that performed the best because then you're essentially just brushing the surface and you're doing these multiple passes. In this picture here, on the left-hand side, you actually see several things on this one. One, you can see that when this field was mapped out, there was a rock in the field, and it was interesting to see how the robot followed the rock. But on the left-hand side of the field, when we came to weed, we purposely left this a little bit too long. So there's about 50% weed cover in this row of crop. And after one pass of the Oz robot, we were down to 23% weed cover. After two passes of the Oz robot, we were down to 2% weed cover. And so this was a very eye-opening test for us. We were quite excited on how this worked. The next robot, and I guess an answer to the question for spreading crops, what is the solution if cultivation doesn't work? So an answer is going to be we need a crop with fingers or a weeder with fingers or arms. And what the Nexus robot does, the Nexus was originally designed in Nova Scotia. They've since moved to Montreal. It uses a set of mechanical fingers to actually reach in between the crop and pull weeds out. And I don't know how well this will show up, but they did play a small demonstration of the Delta arms that reach in. And what I'm going to do here is I'm just going to attempt to pause the video, and you can see in the middle of this video here, you can see the little fingers that are reaching in. And so what the robot does is, as it's going across the field very, very slowly, it will see what is not a plant. So it is trained to recognize the plant in the field. So let's say you tell it that it's doing carrots, so it can see the carrot, or it can see the whatever crop it happens to be, lettuce or cabbage or whatever. And then the Delta arms will recognize what is not a weed, and it will reach around the plant, grab the weed, pluck it out, move it to the center of the row, and drop the weed on top of the soil surface on the center of the row. And that is the goal of the Nexus robot. So it has its place in the spreading crops. So that's kind of what we did in 2021. In 2022, our working group is busy planning what we're doing for next year. So the Oz and Dino products are offered up for sale or lease, obviously, for people that are interested. We are still going to be doing demonstrations across Ontario as much as we can, and as well as the Romeo and Raven products. We are formalizing the use of the robots with farmer cooperators. So I think we are trying to move beyond a demonstration piece. We're satisfied the robots will work and will be commercially viable. So now we're moving into, where are these robots going to be on a commercial scale? That is our plan for 2022. And we'll be working with the Oz robots again. We'll be working with the Oz robots in the market garden, berry, vegetable, nursery side of things. That's where they're going to stay. The Dino robot is going to stay in a 40 to 50 acre field for onions, celery, carrots, that type of crop. That's what it's designed for. There are 2 Nexus robots coming to Ontario in 2022 that we'll be looking after. And we are looking for cooperators and people to work with on these machines. I have some other machines that are coming as well, but they're to be announced. I'm not prepared to make that announcement today as to what they are, but there are some other robots on the way. And I think that's it for my presentation. And I think I'll end it and open up for some questions, if there are any.
That's great, Chuck. I love what you're doing there. It's great to see where this technology and you kind of taking the lead on making this work and going through all the difficulty of finding the right tools to make it work. Question, did you do any side-by-side comparisons on a herbicide versus a program that you use your robots on?
In every case, it was done, but in almost every case, in the side-by-sides, like people came in by hand because the herbicides are not 100% in the manual cultivation. So it's in terms of overall effectiveness, I'm not going to sit here and say that one was better than the other. I would say they're quite equal, other than we didn't need to hire a team of people to come and hoe it manually.
Yeah, that makes a big difference. Plus, as you mentioned, because they're lighter, you're able to get into the ground at times where you wouldn't normally able to do that. So you're that flexibility to be in field whenever you need to. You don't have to wait for weather to improve, which sometimes it might be cause a situation where the weeds grow too fast, and then he can't. So that's one of the things that's a little bit challenging for some people to get their head around.
when we were talking to people about weeding and they were talking about 10 acres a day, they're just like, well, I could normally weed 60 acres a day or whatever. Well, and that is true, but the reality is that people are trying to weed 50 or 60 acres a day, not because they have to, but because that is the time that they have that's allotted to them for that day. That was their task. So if you think about the robot doing 10 acres a day over a 7-day period, well, they can easily look after that 50 acres. Like nobody says it has to be done in one day. And that's where the rotation is. So once it's done for 1 week, well, then the next week it just starts all over again. And it doesn't care. Like it just keeps doing it.
I guess the question was, you were out, you were using these. How's the reliability? Any issues as far as the technology side of things not working? You said you had to do some tweaks, but you got to understand that because it's you're customizing it for your field.
Yeah, I think the largest part is getting used to the platform. I think a lot of the robots seem to use a similar layout and design. So in terms of trying to figure out how they work, once we figured out one, we could figure out the other. In terms of some challenges, like we had a few breakdowns, and we're not really sure what caused them, but the product support from the companies was excellent. We were able to work on them. I'll tell you one thing that is, I am very quickly becoming a true believer in the electric vehicle sector, because when it comes to changing a component, there's no air filters, there's no oil leaks, there's no transmissions, there's no clutch packs, there's no air conditioners to repair, there's none of this kind of stuff. So when it comes to fixing something, like if a component goes bad, you unplug that component, you plug the new one in, and the best part is the computer tells you exactly which component has failed. And so the actual serviceability of the robot is greatly improved compared to some of the other machines that we operate. Yeah,
that makes a lot of sense.
Mm-hmm.
When you talked about the Nexus, could you tell us what you're going to be doing with the Nexus that are coming in?
So what we're going to be doing with the Nexus is we're going to be bringing it into a carrot field, both a carrot and an onion field. Well, I think one of them for sure is going to go up to the Holland Marsh, and we're going to try to keep one of them closer to home. And we're going to dedicate it to a 25-acre plot to basically look after that 25 acres. The Nexus is still very preliminary in its development before they go commercial, but they show a lot of potential, especially in the crops that are hard to weed with a cultivator. And we're quite excited to be working with Tarek and the team from Nexus.
Oh, that's excellent! Excellent. Looking forward to seeing that in action in the spring.
Mm-hmm.
Question from Lisa. Chuck, what do you see as the biggest barrier for farmers to adopt these robots once they're commercially available?
Well, I said this in a presentation. I've heard this, and I don't know whose line it is, but farmers there's a lot of generational intelligence that farmers have when they grow crops, especially the high value crops. Knowledge that's been passed down for years and years. And so because of that, the path of least resistance is to always do things the way I've always done them. And it's a big challenge to step in and say, well, you know what? You are no longer going to plant that 50 acres in one day. You're going to plant that in 3 days. Or you are no longer going to weed that in one day. You're going to let a robot do that over a week-long period. There's a mental roadblock that says, this is what I've always done. We have always sprayed X chemical this many days after planting, and now you're telling me that I'm not going to do that. And there's a mental roadblock in that place, and I think that is going to be a barrier to accept the technology. The other piece from the commercial availability is going to be we need to get our heads around what is an acceptable production level. And when I was talking with Carbon Robotics, another company that does spot weeding, they talk about, it's not acres per day, it's weeds per hour. Like, how many weeds per hour can I kill? And we need to get our heads around, what is commercially acceptable, and what can we handle, and what can we get done. And when I'm working with the Raven products, like when I'm working with OmniPower and those products, we come down to, what is the best fit, and in terms of, how do we, is it labor efficiency, is it cost efficiency, or is it a combination of both? And I think some of those answers are being presented to us with labor challenges that we're all facing in agriculture. We're being kicked down that road kind of a lot faster than we want to be.
Yeah, I think the labor thing is going to be, it really.
It's not about eliminating, and it's not about eliminating jobs. It's about the just availability in general. And so this isn't about replacing people. This is about having somebody, in just having them. And
they become more more high value jobs that end up filling that role. At Carbon Robotics, it's some pretty cool technology too.
Yes, it is.
Talking to them, so tried to get them as a presenter, but unfortunately it didn't happen. But it'd be interesting to see if you start using that as well. Because I'm hoping to make it down to the there's an ag conference in California in February that I'm hoping to attend. I've been asked to attend at that and check that out. So great. So when it comes to these robots, we talked about the adoption of them. Where do you think the price benefit becomes worthwhile for the average person to say, I'm gonna make that? I've gone through it. I get the sell of changing the way I'm doing things, but if I'm gonna put out all this money, where is it going to be beneficial for me? So I talked to a couple of growers that are spending upwards of $1,000 an acre on a single pass of hand weeding. And so for that grower, for 50 acres, they're looking at $50,000. And if a dyno robot is $250,000, you are looking at, easily 5 years pays for that robot. And so I think that the commercial acceptance, once people see that these robots can actually operate for their 8 to 10 hours a day, which we have found they could. Actually, Nail has been very good at being very truthful in what their machines can actually do. That becomes pretty much a no-brainer. And the part that I think makes it a moneymaker is that a lot of times the hand weeding is only done once or twice because it's so costly. But if you tell a grower that, hey, I can give you this much value for weeding, but you can go through your crop 3 times for the same cost, that is where the value is going to come in. So if we bring in a Nexus robot that can weed on a 6-week cycle from May until the 1st of August, you're getting 6 weedings on those 25 acres. And so then that cost becomes actually quite beneficial. Yeah. And that cost does not include the chemical cost either. Like there's also chemical savings as well. Yeah. It'd be interesting also to see what I would imagine there's a carbon benefit as well. And that's going to come later on. And especially as we move into commercial field crops, like once we start moving into corn, soybeans, wheat, these types of crops, we're going to start to see some of the some larger scale benefits. And one of the ideas from a carbon sequestration standpoint is that if we can have a robot that can weed without disturbing so much soil, that becomes an option for people. There's a lot of tillage happens only because that's what we've always done, not because that's what we have to do. Yeah. And I think you're pretty much a no-tiller or low-till, right? Yourselves. So,
Yep.
so going through trash and that'll be another issue that these robots are going to have to deal with.
Well, and this is why we're looking at machines like a Nexus, and we've been working with Small Robot Company on their electric weeder as well, so that we can see the the ability to go through a crop that has high residue. Obviously, horticulture crops, they do require tillage because it damages the root, and you have to, there's some things you have to do, but in other crops, you don't have those barriers, and we're hoping to take what we learn from the hort side, apply it to the commercial side, to the cash crop side. That's the goal.
Yeah, that certainly makes sense. Another question from Lisa: given the shortage of laborers, do you feel that the government will step in to supplement the cost of these robots for farmers to help ensure food security?
Well, I kind of think the answer to that is that they already have. Now, I'm not a huge believer in government paying for everything, because at the end of the day, I end up having to pay for that too. But the government can help de-risk those initial purchases. And so what we're doing, or what the government programs have been doing to date, and I hope that they continue, is they are helping to alleviate some of the initial costs of the machines, so that farmers are less concerned about making that, dipping their toe in the water, making that first purchase and getting going. And I think that is going to help lead the way. And I think, labor and food security is definitely an issue. Like we tend to not, think about that too much in Canada, and probably not as much as we should. And I think if we want to keep seeing locally grown, Ontario grown produce and these types of things, this, the addition to autonomous equipment and weeding and things in Ontario and beyond, or in Canada and beyond, is a requirement if we want produce to be grown here.
Yeah, I think, even when you look at companies like Cubic Farm that have these fantastic vertical farming units that are out there that will allow us to have fresh produce year round that's local, so you don't have the logistical costs or risk that we're having right now, and it's really it's because of the shipping issues and all that stuff. It's getting worse right now.
Oh yeah. And it's only going to get worse.
Yeah, for sure. Well, I think we're down to we got 1 last minute, Chuck, so I'll give you the last word, and also to say to everybody, Chuck did say he's going to have some new information coming out, so I'm sure Chuck will share it with me, and we'll make sure that you get to see it on Farms.com. So go ahead, Chuck, on your last words.
All right. Well, thanks you very much for having me on, and I'm very happy to participate. This is an exciting field. We are very early on in the adoption stage. We are at the tractor versus horse stage in this side of field autonomy. So I think people need to recognize that, and we are looking for farmers who want to be with us on the journey, or on the path to autonomy, as Raven likes to call it. So we're looking for people to work with who have a like-minded outlook, and feel free to reach out. Thank you very much.
Thanks, Chuck. Thanks, everyone, for joining us.